Okay. So my name is Thomas Vanderveen. I assume you guys can all hear me.
Yep.
I can certainly hear myself. So I'm going to talk today a bit about Clojure, hopefully very quickly. So what is Clojure? So Clojure is a programming language. Clojure is a Lisp. So Lisp was invented already in 1959 by a chap called John McCarthy. So it's been around for a long time. And say it's a Lisp. There's lots of different variations of Lisp, and Clojure is a specific one. Clojure is very specific in the fact that it runs on the JVM, so Java Virtual Machine. There's also a version that runs on the Common Language Runtime. And the fact that it runs on the JVM gives you actually lots of leverage. All the existing Java libraries you can reuse, for instance. There's also a version called Clojure Script. Clojure Script compiles down to JavaScript, which means you can run Clojure code inside your browser, and you can run it on Node.js, for instance. So this is a way of running the same code both on your client and on your server. It's a very powerful concept. And there's an example, for instance, a guy who was writing a little program, I guess his breakable toy, and he had all his logic on the client in Clojure Script, and then decided, oh no, that's the wrong place. I shouldn't run it on the client. I should run it on the server. 10 minutes later, all his code was running on the server. You know, had he done that in JavaScript, and he was using Java, for instance, on the server side, that would have been a rather painful experience, for instance. Clojure is opinionated. Clojure says you should do things in this way. It has what they call idiomatic closure as well, for instance. So it has opinions on how things should be done. As I said, Clojure has been designed to be hosted. It's core of the language, which also means simple interop with the host platform. Yeah. So calling Java code from Clojure code is very simple, and that's the whole. It's designed into the language. It encourages functional programming. So functional programming, everything is a function in functional programming. Yeah. So there's no assignment operators now. So I'll show you guys in a minute. Everything is a function. Also higher order functions, yeah, functions that take functions as arguments and return functions as values, for instance. So no objects, for instance. Yeah? It's dynamically typed. Java, statically typed, Haskell, for instance, as well. But Clojure is dynamically typed, even though it runs on the JVM. Which makes it easy to try out things, you know, and I guess it goes back to the breakable toys thing. You can just try things very easily. But there's ways around that actually as well. So other thing about Clojure, all the data structures are immutable. So all the vectors, maps, and arrays and stuff like that, and lists, they're immutable. You can't change them. So one of the gentlemen here earlier on was saying, so how does that work? Well, in immutable data structures, you give a function a data structure, you operate on that data structure, and it returns a new version of that data structure. At first, it's very strange. You know, x plus 5 is a construct I'm sure we've used all at one stage in our lives, or an equivalent. You actually can't do that. You return a new version of x, actually, in that case. But it has lots of advantages, actually. Because they're immutable, that means they're not changing. If you have multi-threaded code, if you look at the data structure, it won't change while you're looking at it, guaranteed. So writing multi-threaded code becomes a lot simpler. So there's no locking required on your part, which gets rid of a whole class of bugs. Because if I've done multi-threaded code here, you know, they're really painful to debug and fix and stuff like that. So it solves a lot of problems. Of course, sometimes you do want to change things, and that's where Clojure has software transactional memory. So just like in databases, you can change things, and it does it in a consistent way. So if I'm changing something and another thread is changing something at that same object at the same time, the outcome will be consistent, and there will be no problems as a result of it. So it can be done. And Clojure is a programmable language, something that's been called, you know. Someone said, if you give a programmer a Fortran, he will write a Fortran program regardless of what will happen. Even if you give him another language, he'll probably still write a Fortran program. If you give him a Lisp, they will adapt the language to the domain-specific problem. And this can be done through Lisp macros. So macros in Lisp are not like C macros, which is just basically token replacement. A Lisp macro is a bit of code that effectively runs at compile time, and it allows you to create new syntax. An example I was giving earlier on is like the unless statement. So Perl, for instance, has an unless statement. Java or C don't support an unless statement. If you really think it should need one, yes, you could go, it's open source language, so you could download the code for the compiler, modify that. You could go to the Java community process and say, no, this is really a useful feature, let's add it. You could wait 5 years, and then maybe or maybe not, it will be in the future. And if you've changed the compiler, certainly your code won't compile on anyone else's compiler. But macros, you just write a macro to do that, and you can write new syntax that way. And now some demos. So obviously you guys want to see how this stuff works. So I'm using an environment called Lighttable here, which has something called an Insta-REPL, which is very interactive. So here, for instance, plus is a function. Yeah? So the list. Yeah? The list is the native data structure of a Lisp program. List means Lisp processing. First thing in the list is the function name, and the rest are the arguments. So. And 4 plus 5 obviously returns 9. By the way, if you guys have any questions at any point, just give me a shout. And so let's define a vector. Yeah, so I have a vector here with 1, 2, 3, 4. A vector is like an array effectively. And if I add something to the vector, it will be added to the end here. So yeah, so 5 is, I've added that to the end of the vector because that's a natural place where you add something to a vector. So V has not changed here. The return value of this function call is effectively a new vector with structural sharing underneath. So it's not a completely new one. Only the things that have changed are new. And functional programming, as I said, functions that take arguments functions that can take functions as arguments, for instance, very powerful construct. And functional programming also means you're not telling the computer how to do things; you just tell it what to do. For instance, so I'll give you a very simple example. Yep. Yep. And now I'm wondering why it's not working. Something is not quite working here. Well, my editor's certainly in a muddle. Oh, it's still doing something. It's probably a bit too much. No, looks like my editor's got Snickers in a twist.
Kill it and start again.
Yeah, that's what I'm trying to do at the moment. So open a new one. Still doing some stuff. Yep, so there we are again. Okay, so what we were driving was reduce. And it still hasn't figured out what I want to do. Right, I think I need to kill this completely. Sorry, guys. Discard all my changes. Okay. Lighttable hasn't quite reached version 1 yet, I must admit, but it's most of the time it works out quite nicely. Of course, when you want to show people, it doesn't. So here we actually see one of the downsides of Clojure. Actually, Clojure, especially on the JVM, it's quite slow to start up. So there we are. Hopefully, this will work a bit better. Because it bootstraps itself, and that takes a bit of time. Yeah, there we are. So, can you guys see this in the back as well? Okay, so range is a function, and I've given it the argument 100 here. So range actually returns the numbers 0 to 99. Filter is a function which takes 2 arguments, well, actually 2 or more. First argument is a function. Even is a function, and it's a predicate. It either turns true or false, whether the input is even or not. And it takes the second argument is the list of numbers 0 to 99. So here, filter returns so even, so that's 0, that's 2, 4, and so on. And reduce again is a function which takes the first argument is again a function plus, and we'd seen earlier on, plus is a function, and it adds 2 plus 4 plus 6 and adds them all up together. As I said, this is more about the what, not so much the how. If you were to do something like this in an imperative language, you would have a for loop, for I equals 0, I equals smaller than the list of the things, and I++, for instance. But I actually is not related to the problem I'm trying to solve. I is actually boilerplate if you think about it. It's not really needed to solve the problem. The computer can work out what I really want to do, what I want to do, not how to do it. So a very powerful construct. And this results in writing actually less code. As I was giving the gentleman in the back earlier on the example, there's a group in Bristol. They used to be part of Nokia, and now they're part of Microsoft. It's called Mix Radio. And they had a big Java project, 44,000 lines of code, Java code, a web service. And no one wanted to change it. It was a big, complicated chunk of code. So they decided to rewrite it in Clojure, and they achieved more functionality in 4,000 lines of Clojure code than in the 44,000 lines of Java code. So it's a tenth of the amount of code they had to write, which also means less bugs. That's a very important takeaway. Because you write less code, you also write less bugs. As you guys see, at no point here I have told it what the types are, for instance. So obviously, if I do, so increment is a function, yeah. So if I increment 2, I get back 3. If I increment a string, I get a Java class cast exception, actually, yeah. So yeah, as a programmer, you still have to do something about it. Am I being too long? Okay. Well, let me quickly then go back to my presentation, just to round it up. So there's lots more. So it's an open source language. It's Eclipse public license. There's a very lively community out there. Lots of libraries. So core.async, which we have running in the background there. So we've got a little demo running in the back there. So please come and join us. Core.async is communicative sequential processes as a library. So actually, basically a new programming paradigm as a library in the language, which runs both on the JVM and on the Clojure script and the JavaScript side of things. Very powerful way to do communicating sequential processes. Core.type is a library, again, to do typing. So you can annotate your functions with what types they should receive and return. And you can effectively have a typed language as a result of it. Core.logic, so logic programming, just like in Prolog. So you set up a set of constraints, and it will do it for you, figure out what the answer is. is a very popular wrapper at the moment for the Facebook React library. It's actually faster than Facebook React because the way the immutable data structures work. It's a very nice way of doing interface programming for the web. Very powerful. So you're probably asking who uses it. So Amazon uses it, for instance. So big companies on there. One of their new the things they use internally is done in Clojure. As I mentioned, the Microsoft one, the Nokia Bristol one. The Daily Mail, not the best newspaper in the world, obviously, but it's one of the busiest websites in the world, actually. And again, they went from large amounts of Java and JavaScript code to a lot less Clojure and ClojureScript code. A big difference. And yeah, as I said, it's a big, busy website, so performance is important for them. So Clojure can achieve that. But yeah, Akamai, eBay, they all use it, and many more. So if you guys are interested, so Clojure at IBM. So Chris Jenkins and I run a little Clojure group here in IBM. You can find us on Connections, that's it. We do every Friday afternoon, we do an hour-long session where we hack away on something. If you want to find out more about Clojure itself, there's Clojure TV on YouTube, with lots of talks from the various conferences, and including lots of introductory talk from Rich Hickey, the inventor of Clojure, which is a really good introduction to it. There's various good books out there, of course. We talked about books earlier. And there's the Google groups as well, where you can ask lots of questions. Really nice community, really welcoming, and no matter how stupid the question you ask, they'll answer it for you, as I found out many times myself.